Hello, everyone. I'm Janine Donnelly, Manager of Webinars for IBM Systems Magazine. And on behalf of IBM Systems Magazine, I'd like to welcome you to our presentation. We will be holding a Q&A session at the end of the webinar. You may ask a question at any time during the event by entering it into the Q&A panel. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. You may download a PDF version of the slide deck by clicking on the drop-down menu labeled Event Resources, and you'll find that on the left side of your screen. There you will also find the ZVT Solution Assessment document, and you can download both of those right from the platform without being disconnected from the webinar. Today's webinar, Virtual Tape and the Efficiency of Hostless Tape Migration, is sponsored by Optica Technologies. Our featured speakers today are Sean Seitz and Gil Fisher. Sean is Vice President of Technical Services, responsible for technical sales, services delivery, and product support worldwide. His 30-plus years of mainframe experience include business management, executive positions in technical sales and support, product management, business development, and consulting services. As Vice President of Engineering, Gil is responsible for Optica's product development team and brings over 35 years of experience in mainframe systems and technology. Gil joined Optica in 1984, where he has architected, designed, and managed the development of the company's many successful channel and storage technology solutions. So, without further ado, Sean, I'll go ahead and turn the presentation over to you.
Thank you, Janine, and thank you to everybody who's in attendance today. We appreciate your time. I want to take just a quick moment and thank Janine and Chris and the whole team at IBM Systems Media. We've done quite a few webinars hosted by this team, and they're super professional, and we really enjoy working with you. So thank you for your support. So by way of an agenda today, of course, we're here to talk about our hostless migration feature, and we're very excited about this new technology. Today, we're making our first public comments about our hostless migration engine. So you're going to be hearing it before anyone else in the industry. So the bulk of the presentation is going to, of course, be focused on hostless migration, but I'd like to provide a little bit of perspective in advance of that section of today's presentation and take about 15 or 20 minutes and set up the conversation and basically pave the way for the deeper discussion that Gil's going to cover on the new feature. So first, I'm going to provide a little bit of perspective on the mainframe virtual tape industry, some of the players that are involved, and how the Optica family of products fits within the industry. I'm going to overview the family of products for you just to give you an idea of the models, the breadth of the family of products we have, and some of the features, including some of the newer features around replication that we offer. And then I'm going to talk quickly about ZVT Control Center. ZVT Control Center is a set of technology tools that run on the mainframe under ZOS. It can be used to control and manage the ZVT system, but in particular, there's a module that's very efficient called ZVT Clone. ZVT Clone is a terrific tape management migration tool that we use as the basis for our services. And the reason I want to cover that today is because it also plays a role in our hostless migration technology. So Gil will cover that in more detail, but at that point is when I will hand it over to Gil, and Gil is going to provide a very nice overview on the new functionality, including a live demonstration. But I want to take just another minute and mention that, migration is a very, very important topic to those who are investing in or refreshing their virtual tape environment. And we hear over and over from customers that migration is an important component in the project, if not the most important. It comes with some risk, and they definitely want to know, how are you going to get me from my legacy system to the new system in an efficient manner where I can be very confident that all my tapes are going to make that transition. So we believe that we are offering in this new functionality an industry first, and so we're very excited about it, and we're uniquely positioned from a technology perspective as a company that's been in the business for more than 50 years, and we focused on mainframe customers and channel protocol technology and storage technology for more than 30 of our 50. So we're in a neat position to bring this to market, and we're excited to talk about it. So again, the bulk of the presentation, pardon me, is going to be delivered by Gil, focused on the new functionality. I will mention also we have 2 poll questions that we're going to sprinkle into the presentation today. So we'd love some audience participation. So we'll ask when we get to the poll questions if you can participate by responding right in the interface here. We'll talk about the compiled results quickly after the results are in, and I think it'll be interesting feedback for everybody involved. So the mainframe virtual tape industry is not particularly large. I think most, if not all, of analysts estimate the virtual tape market for mainframe to be at the 500 million range or less. So by mainframe industry standards, it's not a huge market. And there have been, of course, several legacy players that I call the big 3, right, that have been offering virtual tape solutions to the mainframe market for a very long time, and that's IBM, Dell EMC, and Oracle. And they have very, very good products, very mature, very solid offerings of products. But what has happened in the industry, since it's not particularly large market on an annual basis, as those product lines evolve, they have migrated those products to target the very top end of the market. And that's understandable. I think that these products being very, very solid and very mature, with the market size that it is, it's perfectly reasonable strategy for those companies to be targeting the biggest enterprise clients with their solutions. And frankly, that has opened up an opportunity for Optica. And that is why we entered the market 5 years ago with our ZVT family of products. We feel like the ZVT solution offers an excellent alternative across the entire pyramid, from the smallest customers to the largest. And we're going to talk about that a little bit more throughout today's presentation, of course. But we feel like we have the most flexible, modular, resilient offering in the marketplace, and we're excited to talk a little bit more about that. So to give you a quick idea of the family, the models within the family of the ZVT product line, the flagship product is known as our 5000 INAS. This is the fully integrated modular solution that addresses the smallest requirements to the largest requirements. It can be designed in a very highly available architecture format where there's no single point of failure. The architecture is modular in that it is built from a series of design building blocks, right? So it's made up of really 3 architectural building blocks that will allow you to design the system to match your requirements across the performance requirement, capacity requirement, the data resiliency requirement. So we can tailor those things and customize the architecture of your INAS solution with the virtual tape node and 2 different flavors of storage node, an intelligent storage node and a capacity storage node. The intelligent storage node simply houses the licensed feature set, whereby the capacity storage node is only capacity. So as you're growing your system, you can add capacity storage nodes without interruption to scale the capacity within the system seamlessly. So as far as feature set, deduplication and compression are standard features in the INAS system, and then replication, various flavors of replication, encryption, worm, those are examples of optional features that you can choose to add to the INAS system. And then I mentioned data resiliency. We have a data resiliency technology based on erasure coding, and that is very powerful data resiliency technology that allows you to have multiple hardware failures within a storage node, for example, without impacting your data. The next model is known as the 5000 Flex, and this is a little bit of an industry unique model in that it allows you, the customer, to leverage your own open system storage nodes as the repository of your virtual tapes for the Mainframe virtual tape application. So the Flex system is essentially the engine, right, or the virtual tape node or gateway that attaches to the Mainframe, and then you can attach your NFS or fiber channel storage of any brand or any type to the back end of the Flex gateway. Okay, so this might be an interesting option for somebody who has a very strategic investment in a particular brand of storage, whether it's IBM, HP, NetApp, any brand of storage, where you have extra capacity. You may have infrastructure already established between a production location and a DR location, for example. With that extra capacity, you can leverage that for your Mainframe virtual tape application with the Flex system. So it's not for everyone, but if you fit those categories, it could be a strategic option for you. And then finally, the 3000i, and this is really our entry-level solution or all-in-one product. It is a single-node system that's capable of two capacities, either 8 terabytes of usable capacity or 16 terabytes of usable. Of course, usable after compression becomes larger in an effective manner of either 20 terabytes or 40 terabytes after compression is applied. And this is licensed for 16 virtual tape drives. It supports, of course, replication, compression, encryption. Encryption is coming soon in this model. It's not available today, but will be in the next quarter. And of course, it attaches to all the operating systems or is supported by all the operating systems. So this is a nice alternative for fixed capacity requirements, physical tape replacement, and smaller virtual tape systems. Okay. All of the models are based on the same virtual tape technology, so that's important to understand. The virtual tape node is the basis for all of those models. So I wanted to give you a little bit of a overview of the feature function of the virtual tape node so that you understand where it fits and what the options are for it. First, as far as Mainframe connectivity, each virtual tape node has two FICON interfaces on it. Okay, so if you wanted to scale the performance of your system in an INAS model, for example, you would add virtual tape nodes to the system and you will gain performance in that manner. In terms of virtual tape drive licenses, depending on the model, you can have 16, 64, or 256 virtual tape drives per virtual tape node. Operating systems, all of them are supported on all models. Okay. In terms of storage repository, it's going to vary by the specific model of the ZVT that we talked about previously. The INAS is an integrated 10 gig storage. The Flex model, of course, you can attach with 10 gigabit Ethernet, 1 gig Ethernet, or 8 gig fiber channel, and that again is on your storage. The 3000i offers internal RAID 6 storage, and again 8 terabyte or 16 are the two options with the 3000i. In terms of tape drive emulation, the ZVT system emulates 3490 and 3590, either independently or simultaneously. The feature set, as an overview, we have a very nice GUI system on all models of the ZVT. That's one of the higher rated feedback items we receive from our customers is regarding the graphical user interface. And I might note it offers great flexibility in that you can do anything with the CLI interface and via JCL that you can do in the GUI. So you have some nice flexibility for management and control. In terms of virtual tape libraries, 32 are supported per virtual tape node. In terms of virtual volumes, our largest customer has over 1 million, and we've tested well over 1 million in the lab, so we can support a very high number of virtual volumes in a single system. I mentioned hardware compression, that's standard across all models. In terms of throughput, when we're specifying or building a system for you, architecting a system, we consider from a performance perspective, each virtual tape node offers 500 to 1,000 megabytes a second, and that's a decent range, right? So mileage varies depending on your environment, so we have to be conservative and quote a range. We've seen well over 1,000 megabytes a second per virtual tape node in our lab and in specific customers, but that's how we generally specify the performance metric when we're building a system. In terms of data integrity checking, we offer a very wide range of options, and we feel this is important for your confidence. There's multiple ways that you can be confident in your data relative to CRC checking. So for example, you can set the system to read every block of a library and confirm that it's valid data on a scheduled basis. So you could schedule that data integrity check to run in the background every evening. You can also check immediately after you write a volume. You can check to make sure that everything matches up with the CRC and that you have written a valid tape. So there's multiple ways you can configure them, and you can configure multiple modes simultaneously as well. So that's the personal preference, but designed to give you confidence that the data is going to be there when you need it. And then finally, our file system that we write with the ZVT is an AWS file system. That's a non-proprietary open standard. We feel that's very important. It's the customer's data. You need to be able to access your data at some point down the road. If you don't have a ZVT system, for example, you still have access to your tape data. So we feel that's an important feature. As far as testing and integration, we have a very big investment with all the leading tape management products and vendors in the industry, and we're partnered with all of them. A few are listed here in this bullet point, and I would mention that all of these, not only do we have these products in our lab, but they have our ZVT in their lab to ensure interoperability. And we're proud of the fact that 3 of these companies that are listed actually have chosen ZVT to back up their own business. So they've invested in ZVT after the lab relationships were developed. They've actually bought ZVT for their own production use. Okay, I mentioned the flexibility of the replication options. We've always offered what we call intelligent storage node replication. So that's replication between the 2 storage nodes in a system if you have a production and a DR system, for example, right? We've always offered that. It's an excellent technology. More recently, we've announced virtual tape node replication, which is based on the virtual tape engine, the node itself that attaches to the mainframe. It's available in 3 different alternatives, or 3 options. 2 of them are asynchronous, one library-based, one Valsyr-based. These are the 2 most popular. 1 and 2 here, as you see, are the most popular options used by our customers. And the first one being, again, asynchronous, library-based. You can set this on a scheduled basis. It runs in the background. You can schedule to run, for example, 1 time per day or night. You can schedule to run once per hour. You can schedule to run every 10 minutes. That's up to you. It's customizable and set up at implementation time. We also have number 2 here, Valsyr-based asynchronous. This is similar, but it's based on a configured set of Valsyrs that you want to asynchronously replicate. So after each volume is written, after the rewind unload command, the tape is unmounted, the Valsyrs are in a queue, and those are executed, the replication is executed as a background task in sequence from the queue. Okay, you can do that to 1 or 2 destinations. That goes for all 3 of these modes, by the way. They can be configured for 1 or 2 destinations. And then finally, the 3rd mode is a synchronous replication mode. And this is also Valsyr-based, or set up on a range of select Valsyrs. And as we all know in this business, synchronous is not a commonly used application because of the performance impacts. The tape remains mounted while the replication is taking place, so it does impact job time. So it can be used, but it must be selectively used in most cases. But it is offered, and it offers, I think, from our perspective, the most wide and flexible set of options in the industry when you consider our ISN and VTN-based replication options. This is just a graphical representation that is an actual customer setup. And you have your traditional product production data center on the left, DR data center on the right. Across the top, customers using asynchronous library-based, where they've set up a schedule. So every night at 2 in the morning, for example, they replicate the library, every library in the system to the DR site, okay? And that's done over an encrypted link. You could also set up a second destination. For example, if you wanted a 3rd copy of the data, you could set up any NFS target could be your second destination. It doesn't have to be a ZVT system. It could be a storage gateway, an NFS storage, sorry, not storage gateway, storage node. So it could be any NFS storage node that could serve as your second target for this replication type. And you could do that as a vault. You could set up a storage node in the third location, essentially use it as a vault where you're parking a third copy of your data. On the left side here, you can see within the production data center, we have replication configured down to a cloud gateway. So in this case, the customer is configured synchronously using synchronous replication, right? Where it still is a background task, but after the tape is unmounted, the replication kicks off. In this case, that's a very fine alternative for several of our customers. You could also notably write tapes directly via the JCL. You could configure your JCL to do a direct write to the cloud as an alternative. You don't have to do it as a replication job. You can do it as a direct write as well. And then that data is written out to the cloud. So given that this cloud gateway resides in the same data center, a synchronous replication methodology here could very well make sense. It does for several of our customers. So that's just an example of the flexibility of the VTN replication options that we have. Okay, so just a quick comparison. I did mention we've offered storage node replication or ISN replication. That takes place between the two storage nodes in the system, as you can see on the top. And then the newer offering is VTN replication, which occurs between the two virtual tape nodes. So just a quick comparison. There's various attributes of each that make sense to customers. We have several customers. In fact, all of our multi-tenant customers happen to be service providers. So companies that provide DR as a service or hosting services for mainframe customers where they've standardized on the ZVT system as a multi-tenant system housing multiple customers. Those are perfect examples where several types of replication could make sense. So again, the VTN replication can be from VTN to VTN or VTN to cloud gateway, VTN to any NFS mount point. And the advantages of VTN replication include individual VolSeer granularity. You can configure it by VolSeer range as opposed to an entire library, offers attachment to cloud gateways, offers attachment to a vault in a third location if you wish. As opposed to ISN replication on the right, that's file system based, only asynchronous, and the biggest advantage is it's WAN optimized. Only changed and deduplicated data is replicated. So a quick example of that just occurred this week. We just implemented a brand new customer. They happen to have one of their libraries that they initially replicated that was 10 terabytes in size, and the initial replication took about 8 hours. After 2 days of additional backups, the deduplication technology of the INAS system kicked in, and that same 10 terabyte library, the replication took less than 30 minutes. So that's an example of WAN optimized. They don't have a very high bandwidth link. In fact, it's a very low bandwidth link. And so after the first replication, it took 8 hours. They were a little concerned, but quickly recognized that after the deduplication technology kicked in, the WAN optimized replication was perfect for them and reduced the replication job time down to under 30 minutes within just 2 days. And that's going to continue to go down as the replication, deduplication continues to work for them. Okay, I'll mention ZVT Control Center. Very quickly, this is a set of powerful tools that run under ZOS that can be used to control and manage ZVT. One particular module within the ZCC toolset is called ZVT Clone. It's a migration tool. I mention it because we use ZCC to deliver our turnkey migration services. But I also mention it because it can be configured in the hostless, with the hostless migration function that Gil's going to cover next. So suffice to say that today we deliver traditional migration services in a very efficient manner based on ZCC, as all virtual tape providers deliver migration services, but we think we deliver them very well And in a large part, that's because of the ZCC technology. So I want to give you a quick graphic before I hand it off to Gil. And this is a little bit of foreshadowing on the new feature, but this just demonstrates sort of the setup or configuration of a traditional migration on the left versus the Hostless Migration Engine at work on the right. Okay, so as you can see on the left, a traditional migration, of course, you have ZVT Control Center, in our case, installed on the mainframe. You're reading tapes in and writing them out from a legacy system to the ZVT. Whereby on the right-hand side, you still have connectivity potentially as one option in configuring hostless migration to the mainframe for your legacy and your ZVT systems, but you're moving your tapes directly from the legacy system to the ZVT. So I wanted to offer that graphic, quick comparison of the two. Gil's going to talk in much greater detail here now, moving forward in the presentation. One final comment is I just wanted to reference that the ZVT graphics you'll see from here forward are very simple. We've just used our single node system, but anytime you see this ZVT graphic from here forward, recognize that it could be any of our ZVT models. It could be the 3000i, the Flex system, or the fully featured INAS system. And for simplicity purposes, we're simply using the single node in the graphics. Okay, so that brings us to our first poll question. I'd love for everybody to participate in this poll question. Pardon me. So the first question is, when you're moving to a new virtual tape system, how do you view the impact of the data migration piece or component? So the question really is, when you're considering moving, is the impact of data migration high or low, or no impact? So if you could enter your answer from A, B, C, and D, high, medium, low, no impact, we will compile the results, and then we'll talk about those results. What we've found, and it's going to be interesting to see what the audience thinks, but what we've found when we're talking to customers and prospects and designing systems, it's the first or second thing out of their mouth, right? Every customer wants to know, how are you going to get me from A to B? How are you going to get me from my existing environment to the ZVT system without risk, accurately, in a timely fashion, without using all of my team and my time? So it's a very important question. It'll be interesting to see what the audience thinks here, and as we compile this.
Hey, Sean, I think this looks good. I'm going to go ahead and send these results out to the audience.
So, so we're going to post the results here, I think momentarily. Stand by, and we'll see what comes back. So hopefully you can see the results here, and I guess I'd say, as expected, the vast majority of the audience, more than 91% of the audience, has said that the migration piece of a virtual tape refresh is a high impact or medium impact consideration. So that really does map to what our experience has been, that the customers need to feel confident that their vendor is going to be able to move them to a new system and do it in a manner that's efficient and accurate. So thank you for your help with that. Appreciate it. So going back to the slides, this is the transition point where I'm proud to hand over the reins to Gil Fisher, our Vice President of Engineering. And with that, Gil, I'm going to turn it over to you.
Thanks, Sean. But before I begin, I just want to ask everybody to bear with me. I have a little bit of a cough. I'll try to mute before I cough so I don't blast your eardrum. But I think we're on the first slide there of hostless migration. So what is ZVT Hostless Migration Engine? In short, simple terms, it's the ability of the ZVT to connect directly via its FICON interfaces to a legacy tape system and read those tapes from legacy system without any attachment to the host or minimal attachment to the host. What are the benefits of hostless migration? Clicking the wrong spot on the slide here. The ZVT can connect directly to legacy tape systems by using either a graphical interface. Well, it connects over the FICON interface, but you can control it from a graphical interface or command line interface. there's no mainframe, because there's no mainframe involved, tapes are copied with no host MIPS or I/O cycles. Because the tapes are read from the FICON interface on the legacy tape system, an exact copy is made as it was originally written. It doesn't matter if the source was written in a proprietary manner, because it will be read just as if the Z host was reading it. No special hardware is required. Hostless migration is executed on the same ZVT that is or will be used in production. The ZVT can be in production while it is migrating tapes. It simply needs to have the license feature enabled. The ZVT emulates a host channel connecting to legacy tape systems via FICON attachment. This can be physical or virtual. Optica Technologies has been emulating host tape channels for many, many, many years in our labs. We used that technology when we were designing our conversion products that we've been selling forever. And so we have the ability to completely control a device with any possible I/O that a system can send. We simply leveraged this capability when we brought hostless migration to our ZVT product. You can define up to 32 migration devices can be configured in the system. Of those 32, 16 can be simultaneously reading tapes from the source tape technology. Virtually an unlimited number of tapes can be in the queue, but 16 devices will actually be used, up to 16 devices, depending on what the requirement is. Up to 16 devices can be reading tapes at once. Migration can be controlled by the ZVT's graphical user interface over web connection. It can be controlled from a command line interface via secure shell, or from the host via what we call ZVT command tape. ZVT command tape is simply the ability of the host via JCL or application to write a special ZVT command tape. Each block on that tape will contain one command that the ZVT can execute. Following the ZVT executing those commands, you can read back the same tape and the results from those commands, one per record or one per block. The result of what was the commands that were executed in ZVT the results will be returned in that data set. I'm going to demonstrate each one of those controlling interfaces shortly. Tape management synchronization. There are two ways that we can synchronize with your tape management system. Scripted via ZVT report processing capability. With this capability, you can send down to the ZVT a command followed by a data set that's actually a tape management system report with volsers in it. It could be a scratch list, it could be, whatever report, whatever volumes that you need to execute a process on. One of those processes we're going to talk about today is import. So you could take a report from your tape management system, send it down to ZVT, and tell it to import those particular volsers from the legacy system. Any function that you can do from the GUI, command line interface, or from the host can be acted on from that list of volsers. So again, the ZVT will read that report, find the volsers first, sort them, put them into ranges, and then execute any kind of command on them. You could scratch them, you could retain them, you could write protect them. All those things can be done via the report from the system. Next, through ZVT Control Center, the ZVT software run on the host can interface to your tape management systems, move the tape, move the tape via hostless migration to the ZVT, change the assignment so that you can be using your legacy system and the ZVT at the same time. The only time that the tape will be unavailable to you, or the tape set will be unavailable to you, is during the actual migration of that tape or small set of tapes. They will be moved, and the software handles the new allocation. Remember that while that's happening, there are no MIPS or I/O cycles for the host while the copy is happening. The commands that are sent down from the software are very thin. It basically uses EVT command interface and then a little bit of catalog manipulation. That's the only things that would be used in host MIPS. The copy of the tapes will be done all offline from the host. There are two modes that the ZVT can be in hostless migration, standalone and concurrent. In the standalone mode, as you see here, the ZVT has two FICON channels, both connected to the legacy tape system. In this mode, obviously in this mode, there's no interaction with the host, therefore there are 0 MIPS and 0 IOs happening from the host because the host is not even connected. In this mode, you can only control the import via the graphical user interface and the command line interface. Obviously, there's no host connection, so you couldn't control it from the host. So ZVT emulates FICON host channels here and then talking to the target tape device. In the concurrent mode, the ZVT can be migrating tapes from the legacy system as well as be online to the host for normal tape operations and control via ZVT command tape. Additionally, there's no problem with the host accessing the legacy system over other channels. Obviously, the saved tapes can't be accessed at the same time. That's one of the things that ZVT Control Center would manage, the migration of the tapes from here to here, and then the host would not have to deal, nothing that you would have to do, that's handled by the software and interface into your tape migration system. In this concurrent mode of operation, you can control the ZVT. Not only can you read and write tapes, but you can also send commands down to the ZVT to do the migration. So you can use all three forms of controlling interface to the ZVT. You could do it from the command line, from the graphical user interface, or from host control. Again, demonstrating those in the demo shortly. The first mode in standalone from the GUI control, boy, this, I hope that this is seeable. I will, I'm demoing this and it'll be definitely large. In this case, this is a ZVT graphical user interface showing what we call the tape management screen. From this screen, you can search for VOLSERs based on almost anything. When it was written, well, literally anything. You can find those VOLSERs and then act on them once you found them. In this case, what we'd want to do is import. So I select these three tapes, select the import command, and then we would read those tapes from the legacy tape system into the ZVT. One thing to note is that the VOLSER ranges, we call those policies. You have to have the policy must exist on the ZVT before you can actually import it from the legacy system. And we'll demonstrate that shortly. So that's how you would talk to it, how you would affect an import from the graphical user interface. From the command line interface, it's simply, this is the command that you would type. I'm going to defer, because I think we're running out of time. I definitely want to get to the live demo, so I'm going to defer going into great detail here, because I'll show you it actually in a live demo. And finally, we can do the same thing. This is the third way of controlling the ZVT. And this way, this simple one-page JCL can affect the same import that we showed in the other two modes. Again, I'm not going to go into great detail because we're running low on time. Finally, just for completeness, I'd like to show something about, a little bit about how you would, from a JCL, how you would do a report. So this is a RMM report. These are the VOLSERs. Again, you would send down a command to the ZVT, and then you would find the VOLSERs based on some parameters that you put in that says where these VOLSERs are on this report. And then we could do two actions. We could create the VOLSERs within the ZVT and then import them. Finally, a little bit about setup, and I'll demonstrate this as well. Excuse me. There are, on a ZVT, there's actually 3 modes, but in Hostless Migration, there's only 2. But to set that up, it's very simple. You go to the Modes tab, Devices, Menu, Modes tab, and you would set None for normal operation. In that case, both ports are emulating 3490 or 3590 tape drives. Both ports are normal virtual tape functionality. Then because what we were doing is selecting the migration port. If you select port 0, that's one of the concurrent modes. Port 0 then would be used to connect to the legacy tape system. Port 1 then would be free to connect to the host, acting as a ZVT. So in the concurrent mode, the one port is target, acting like a virtual tape appliance, 3490 or 3590. The other port is acting like a host, connecting to the legacy tape system. Finally, if you select port 0 and port 1, that's the standalone mode that we talked about previously. That would allow you to connect 2 ports to the legacy system and read twice as much data, or twice as fast. Finally, you need to set up migration devices. So you would select a device number. This is an arbitrary value. It doesn't mean anything other than a tag that you would use later basically just like on a ZOS system. But we would typically say make that device range the same as it was when you were connected to your legacy system, so that there's no confusion about which device that you're using to read and write to read the tapes from. Give it a range of the number of devices you want to use, a free LPAR that's not being used on the system, the control unit address, and then the unit address, and then the port on the ZVT that's connecting to the legacy system. I know that was pretty fast, but hopefully the demo will be more understandable. I think now Sean's got another poll question he would like to ask.
Okay, thank you, Gil. So yes, so our second poll question should be posted. So when you're planning a tape refresh project, how much would you value the ability to do the actual data migration without the use of mainframe cycles? So again, when you're planning a refresh project of your existing tape environment, physical or virtual, how much would you actually value the ability to do the migration without the mainframe? So as we compile the results here, we're going to post them. So we'll give it a few seconds, and then we'll chat about it. I expect we're going to see a relatively high percentage indicating they view it as a high value feature based on the feedback we've received from our customers and partners, but we're going to find out in just a moment here.
Hey, Sean, it's Janine, and I want to give this just one more moment, but I thought it's a good time to remind folks who joined late, because there were quite a few, that you can download a PDF version of the slide deck, and just based on the number of questions we're getting, I think you guys would find that valuable. So Event Resources is located on the left side of your screen there. Click on that drop-down menu. You can download the deck right from there without being disconnected. So Sean, I've just sent the results back out to the audience.
Thank you, Janine. Okay, so this is interesting. As expected, a high percentage of folks have indicated that it is valuable. It's very valuable to be able to migrate without use of the mainframe. So that's consistent with our expectation and gives us some excitement around our new feature set. So thank you for your participation there. So Gil, I'm going to transition back to you, and I think you're going to.
Okay. Hopefully everyone can see my my screen there. I lost the other screen. So anyway, okay, I'm just going to start doing the presentation. What I'm going to start with is the devices screen that we talked about earlier. Actually, I'm going to show you the lab. So this is the way the lab is set up. We have a Z114. We're connected to DLM 8100 and a ZVT with internal storage. Again, as Sean said earlier, remember this can have an iNAS. It can be multiple ZVTs connected together, connecting to the storage pool. But for simplicity, we're just showing a single ZVT. Sorry, sorry. So that's the configuration. So on the devices screen, you'll see that I've got a virtual device. That's my ZVT port. It's defined as F140 for a range of 16. That is this link right here going into the ZVT acting like a virtual tape appliance. Then over in migration devices, I have two ranges. I have C00 for a range of 10. LPAR is C0. We'll notice over here, that's this link here. So I'm on LPAR 0C. Oops, C0. I think I got that backwards. But anyway, and then I'm also connected on C00 to C0F on LPAR 1 for the same storage system. In addition, to show you how the modes are set, this is how we selected. I showed the screen earlier. This is how I say whether the ZVT is in standalone mode, acting just as ZVT, or one of the two concurrent modes. If I change the mode, it will say, hey, just as a warning, we're going to reconfigure the ZVT. Do you want to do that? We're not going to do that now. Okay, so now we're going to go to the library screen, and I'm going to show you first that we have some ZVT command tapes. We talked about that earlier. When we use ZVT command tapes, command 0 through 7, those are the tapes that we'll use. Back to the library screen, as I said earlier, I cannot import from the DLM, which we'll look back over here. The DLM currently has these valsers with data written on them. So DLM 0 through 9 are the 10 on the DLM. We want to bring those into the ZVT, but we have to create the policy first. So to do that, one of the ways we can do that is by the add policy. So the policy is going to be DLM 000 for a range of 10 to this storage location, which could be on the ZVT or it could be your storage. We are going to, it needs to be a data type, not Scratch. And this is how we would have said ZVT command FY, just to let you know. These are Scratch synonyms. If it was in the Scratch pool, these are synonyms that could be used to call the tape from the Scratch pool. Again, we're not going to set that now. This is the initial label. That's going to get overwritten with the import. So whatever the state of the tape was, whatever was on the tape is going to be exact. So that will be irrelevant in a migration. This is the size going forward of the tape. That's the maximum going forward that the tape can be written. But for the migration, again, it won't. This will be irrelevant. If I've got this set to 1 gig and it's a 1 terabyte tape, it's going to write the whole tape. Next, we have compression. If it's set to never, always, or host control. In this case, never won't compress it when we import. Always will always compress it, and host control will also always compress it. But going forward, when that tape becomes in production, it will only be compressed when host control wants to compress it, or when the host says to compress it. Expire flag, real quickly, that's just, we'll look at the date in the header record 1, and we will expire the tape or automatically scratch it after that date. Protect on close means we will automatically write protect the tape at close when the job is finished writing to the tape. Lastly, we have a nice feature. It's called read after write. You can disable it. You can set it to be async, which means after the tape is written, it will put in the queue to go back and integrity check to make sure that it's written okay. We can do that also synchronously, which means the job will suspend until the tape is written. So I'm simply going to add those valsers or add that policy, and we'll come over here and we'll list the policies, and we'll see that we now have this new policy. And we're going to, in that policy, we're going to now look at the tapes that are in that policy. You'll notice a few things here. This is information off the tape. That is because I selected this view. I created and selected this view. There are other views that you can have that show way more information about the valser. But for this demo, we're concerned about the import view, which shows us the import status when it was last imported. So how then are we going to import those valsers from the DLM? I can select one, or two, or I can select some, or I can just say select everything that's found by this search criteria. And I can add to the search criteria. I can say I only want stuff that's a DSN name is something or another. I'm not going to do that now. But anyway, once I've selected the tapes that I want to do, select all the ones that were found by this criteria, now I can do many things. I could scratch those tapes. I can protect them, write protect them. I could convert them back from scratch, take them out of the scratch pool, put them back in the data pool. I could unprotect something that's been protected unless our worm feature is enabled. We can scratch delete, which will not only scratch the tape, but delete the data associated with it. This particular scratch would only scratch it, put it back in the pool, at the back of the scratch pool, but it wouldn't delete the data. Delete will delete this policy, but not the data still. The data would still be there, and if you recreated the policy, it would use the Valser from the policy. Import, which we're going to talk about now. So if I wanted to import those volumes, I select the migration devices that we defined earlier. I'm going to use the 10 devices from C00. I'm going to say import, and then it's going to ask me, are you sure you want to do that? And yes, I am. So immediately we see that all 10 of those tapes went into the queue. So what's happening now is they went in the queue, and we're going to start reading them from this CLM into here. So to hit this, I'm just refreshing. And you can see, remember, there were 184 bytes because they just had header labels. And you can see that the tapes are being imported. These tapes now are not in progress because they're done. They were 100 megabyte tapes. Now everything's done. We did just a 2.2 gigabytes, 3 400 megabyte tapes, 3 200 megabyte tapes, and 4 100 megabyte tapes. So for the purposes of, again, I'm going through this a little faster than I wanted to, but we're going to, again, select them all. Now I'm going to scratch delete them. So now you'll see that their file size is 270 instead of 184 as it was before, because we left the header record there so you could see what was on them, even though we deleted most of the data from those tapes. Because I can't import to a scratch tape, I have to turn them into data tapes, so I'm going to select all found again, and I'm going to retain them. And now that set of tapes is our data tapes. So now I'm going to show you how we would import using the command line interface. Instead of explaining this a little bit more, so I will. We're going to use the import command. We'll give it the starting Valser, the range, the path on the ZBT that we want them to go to, the starting device number, which is a migration device in this case, and then we'll set the verbose flag. Hit enter. You'll see that they got queued. And if we go up here and hit our refresh button on our tape management, you'll see that they're in process again and migrating. So lastly, I will show you how we use the host control to control the ZBT. And we'll just get one more second here. Everything's been imported. So the first thing I'll demonstrate is a little job I called HM Clean. So I'm using a standard IBM utility, IEB Jenner. The output device is F140, which, referring back to here, is the ZBT. The Valser I'm going to write to is CMD00, which signals to the ZBT that this is a special tape and not just a normal, everyday customer tape. The input will be 2 sets of 3 records for a block size of 240, and then this is a command that I'll send down the ZBT. The first thing I'm going to do is scratch, followed by delete. So I'm going to scratch the Valsers and delete them completely from the system. Because I said keep, the tape will rewind unload. The second step says read back that exact same data set. So in both cases, it's user GHCF000. I'm going to read back the data set that we just wrote. The difference is it will have the results in it. And I'm going to take it to the job output. So when I submit this job, if we go back to the ZBT now and refresh, those Valsers are gone because I scratched and deleted them. We take a quick look at the job output. we will see that we did say verbose. We'll see that this is the output that came from the tape. This is the 2 records that came from the tape. Excuse me, sorry, 3 records. But because we set the verbose option, we told you all the tapes that were scratched. We scratched this one, we scratched this one, scratched this one. So that results of that job went to the output. You could have wrote it to a file just as well and processed it. So now we'll go back over to here, and now we want to do an import, but before we do that, we have to create the volumes. So to create exact same JCL, except in this case we're going to do a create command instead. We'll use the same options that I used over here when I created the volumes originally. We'll do the same thing. We'll submit this create, and again now we come back over to here and do a refresh. We'll see that we have the 10 volumes. They're brand new, so they have 184 bytes. Compressions they've never been imported, right? So not much to see in the output, so I'm just going to go to the next step. So finally, we've already done the import from the GUI, and we've done it from the command line. Now we're going to do it from JCL. So same exact JCL that we had before. We're going to send an import command down to the ZVT saying that this is the VOLSER for a range of 10, and we're going to use this device range to do it. We submit that, and the first thing I'm going to do is go over to the job output, and show you that it's already done. Here's the job output for it. But if we come over to here, we'll see that we're actually just getting started on the import. So the job is complete. There's no other IOs being used, no host going on, but we commanded from the host to migrate the tapes, and they're almost done. So I know that was quick, but at this point I'm done with the demonstration. If you have questions, please let us know. And with that, I'll hand it back to Sean.
Okay, thank you, Gil. We appreciate that. So we do have a few questions, or we do have a little bit of time, a couple minutes for questions if we want to take some, Janine. Does that work?
Sure, we can take some. So folks, we are not going to be able to get to all of the questions. I know our experts from Optica have been answering many of our questions, typewritten answers throughout the webinar, but thank you for all of your questions. We appreciate them all. And if we don't get to your question today, someone will reach out to you via email to get you an answer. Let's try this one, Sean. What configuration changes are required on the IBM mainframe and the legacy virtual tape system to support ZBT Hostless Migration Engine?
That's a very good question. The short answer is no configuration changes are needed necessarily. However, depending on how we want to configure the hostless environment, and there could be some relatively minor device configuration changes in the legacy system as well as the mainframe system. So I guess in summary, not necessarily any changes required unless we want to, unless we need to make some device config changes for efficiency, for example. So I'd say perhaps. It depends. It depends, but I would say not necessarily.
Great. Okay, and as we reach the top of the hour, I've just advanced to this slide because so many of you had questions. I just wanted to get you some contact information. So note, under each of these names, it's difficult to see, but there is a live link. So if you click on that, say you have a technical question you'd like to direct to any one of these gentlemen, click on that link now. It will literally open an email, and then you can just copy that email address so that you can reach out when it's convenient for you. And sadly, we have run out of time for today. So I want to thank everyone for attending today's webinar, and I especially want to thank Sean and Gil for sharing their expertise with us today. Later this week, Watch for a follow-up email. It will contain a link to the recording of today's webinar. That concludes our webinar. Thanks again, and have a great day.